All right, well, good morning, everyone, and welcome back to another exciting day in mathematics. How's everybody doing? Good? Yes, Mr. Q. So warm-up number 60 is on the screen. By now, you should be able to do all 5 of them. Number 1 reads, make an input-output table with the domain -4 to 4 for the function f of x equals 1 over x. Plot the points and graph. Number 2, graph f of x equals x squared. Then transform given g of x equals 2 times f of parentheses x minus 4, close parentheses, minus 3. Number 3 reads factor. Part A reads x cubed plus 4x squared minus x minus 4. Part B reads 5x squared plus 11x plus 2. Number 4 reads divide the polynomial with synthetic division. Polynomials given are 2x cubed minus x plus 3 divided by x plus 3. And number 5, solve the quadratic equation y equals x squared plus 4x minus 5. Work on those. I'll give you guys some time, and then I'll come right after to ask for participation and go over some of those. Ready, go. All right, so let's see what we got. I'm going to go over numbers 1 and 2, and then move on to the next one. So here we go. Hold on, let me make some space here. All right. So we're going to start with the graph. So like I said, this should be reviewed, and you should have made a table from -4 to 4 on the domain or all the x values, and then gotten some fractions for your, or most of the fractions for your range. But the graph for f of x equals 1 over x should look something like this. Yes. Yes, Mr. Q. And once again, rational functions, we're getting closer and closer to those. We're about to get there. Number 2, it says graph f of x equals x squared. So the parent function f of x equals x squared goes through the point of origin. There it is. And that function looks like this. So -1 squared is 1. -2 squared is 4. So this is 1, this is 4. And then that reflects on this side. Something like that. All right. However, they want us to transform it according to these parameters. So what parameters do they give us? They give us h, they give us k, and then give us a. So according to those parameters, they're telling us to go to the right 4 times and 3 down. Or our vertex, instead of being 0, 0, is going to be now 4, -3. 1, 2, 3, 4, and then 1, 2, 3. However, before I graph it, I want to know what this a value is going to do to the entire original function. Who remembers what that whole number will do to the original parent function? Chime in whenever you got it. One at a time. So really, Mr. Q, we're coming from Easter break. Come on. You should have been doing your practice. My goodness. So, quick recap. Before we left to break, this, I included a negative. What did the negative do to the original? It flipped it. Yes, I see some of you flipping it. Yes. However, this one's not a negative. It's a positive, but it's a number, a whole number. So what does that do? It stretches it. You guys remember that? It stretches it vertically. That means that this original is going to look like this. Watch, I'm going to show you in red so you guys can see how it stretches. It's going to stretch like this. How do you know, Mr. Q? Because this too is going to multiply our y values. So what are my y values? The first one is 1. So 2 times 1 is 2. So this point, instead of being at -1, 1, it's going to be at -2, 2. This one, instead of being at -2, 2, 4 times 2 is 8, so it's going to be a -2, 8. And then it reflects to this side. So basically it's a multiplier. That's why it stretches. So if that's what it did over here, that means our final transformation over here is going to look like that, stretched. There you go. Okay. All right. I'm bringing it back little by little because we're going to be seeing more of that. All right. Let's go to number 3. Let's see. Number 3, factors for 3a. What'd you get for 3a? Octavio. Factors. Octavio. Okay. Help them out, Mia. What'd you get for your factors for 3a?
X plus 4 and x squared minus 1.
Bam, Mia, let's go. Yes, so far so good. So far. You're like, what? Yeah, look up. Doesn't this look like we can factor it a little bit more? Yeah, it's a difference of squares. Difference because it's subtraction. It's a binomial. Let's try it and see if we can. Square root of the first. Oh, x and x. Square root of the second. What is square root of 1? +1 and -1. There you go. So my factors are x plus 1, x minus 1, and x plus 4. All right, passing one, Mia.
Anthony?
Anthony, what are factors for part B?
I'm still working on that one.
Okay, we'll come back to you. Number 4 says divide the polynomial in synthetic division. I'm going to go over that just for the sake of time. This is to the 3rd degree. This is to the 1st degree. 0 degree. Which degree is missing? The 2nd degree. Okay. 1st degree, 0 degree. All right. So to start my synthetic division, I start with this, which is -3. My coefficient for the first power is 2. My coefficient for the second power is 0 because there's nothing there. My coefficient for the first power is -1, and my constant is 3. -3 times 2 is -6. Combined, that's -6. -3 times -6 is 18. Combined, that's 17. -3 times 17, that's -51. Combined, that's -48. So what's left here on my quotient? 2x squared minus 6x plus 17. And then we have -48 over, what's my divisor? X plus 3. And that's my quotient. All right. Anthony, let me know when you're ready.
Oh, I'm ready.
Okay, what'd you get?
5x plus 1 and x plus 2.
Let's go. Anthony in the house. You are in the house, right? See what I did there, guys? In the house. Huh? Anyways. All right, number 5, it says solve the quadratic equation. What is the first thing we do to solve a quadratic equation? Set it equal to 0. Change the y equal to 0, x squared plus 4x minus 5. From there we factor, -5, +4. Factors of -5 that add up to +4. That's 5 times -1. 5 times -1 is -5. 5 plus -1 is 4. So since this one doesn't have a leading coefficient, I can write it as x times x. And this is +5, and this is -1, all that equal to 0. And then set each one equal to 0, x plus 5 equal to 0, and x minus 1 equal to 0. Let's solve. -5 minus 5, x equals -5, plus 1, x equals 1. And these are my solutions, of course. However, what else? They are my roots. They are my zeros, or my x-intercepts. We need all those terms by now. Now, why are they solutions? Because we just solved for x, solutions. Why are they zeros? We already know, because if we substitute these values in here, what does it give me? 0, yes. Why are they x-intercepts? Because if we graph this is where the graph crosses the x-axis. However, some of you might have forgotten, why are they called roots? Let's see. Quick recap. When we got to these, before we got to those, I remember I gave you a question, and I said, if I give you an area, and I said the area is 16, here's the square. How do I find the measurement of this side and this side, being that it's a square? Well, you take the 16 and do what? Yeah, square root. What is square root of 16? 4 and 4. That's why they're known as roots. So these, even though they're not squares, they still have 2 dimensions. They come from the area model for rectangles. You guys remember that? So therefore, this would end up being x squared plus 4x plus x squared plus 4x minus 5. And the measurements of the side would be what? X plus 5 and x minus 1. You guys remember those? If we multiply them, so on and so forth. Yeah. All right, let's move on. Our agenda for today, warm up number 60. Copy that, please. We're still on polynomial equations and zeros. And tonight's home place, pages 348 and 349, numbers 1 through 12 only. 1 through 12 only. Okay. Once again, warm up number 60 we just finished. Today we're still on polynomial equations and zeros. And your home plate for tonight, once again, pages 348, 349, numbers 1 through 12 only. Okay. Your asynchronous session code, copy this down, please. VC2T9. 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 So once again, make sure you go to that, turn in your notes, and yada, yada, yada. You know what to do. Okay? So let's see. Did I give you any home plate for the break? Yeah? Bam, let's go. Yeah, pages 348, 349, odds only. So go to Canvas, turn that in. Some of you already did. Thank you very much. And once again, reminder for tonight, I'll give you some time for that. Tonight, you are working on pages 348, 349, numbers 1 through 12 only with the graph. And some of you might be thinking, Mr. Hugh, didn't we already do those 2 pages? Yes, but did you graph them? No, that's what we're going to be doing today. Let's go. Let's go. So get a Cornell note ready. And we'll get started. I'll give you some time to turn that in. All right, so let's move on. Here we go. Our objective for today, I can identify rational zeros of polynomial equations. Our objective for today, I can identify rational zeros of polynomial equations. If you notice, we're still on the same objective, same concept, and by now, hopefully you know what polynomial equations are. Yes? Yes, Mr. Q. So in your Theorem model, write polynomial equations, and I want you to give me a definition, one example, one unexample, and a hashtag. See if you can do that without looking at your notes. I mean, not that you guys do that, but I mean, just let's see how you do with that. I'll give you 1 minute. Copy that and go. So once again, you should have filled your Theorem model, polynomial equations by now by looking at each term, polynomial equations. That should give you a good clue as to what the definition is. So you should have written your definition, one example, one non-example, and one hashtag. All right, so you can finish that on your own. It should look something like that. Okay, So quick recap. Last time when we met, and the previous time before that, I went over zeros and rational zeros. Zeros, we now know, according to the warm-up that we just did, are when we solve an equation, the x values are solutions, our roots, our zeros, or our x-intercepts. And why are they called zeros? Because if we substitute them into the original equations, they give us 0. Why are they called, what is a rational? Any number that can be written as a fraction. So if they are called rational zeros, it's because whatever we solve and we get, when we substitute that into the equation, it could be equal to 0. And those numbers that we substitute can be written as fractions. Okay. From there, we moved on to rational zeros theorem. What did the theorem say? It said that if you take the constant divided by the coefficient, or the leading coefficient, it should give you factors, and any of those factors could be the possible rational zeros of the equation or the function. And we did plenty of that. We did example 1, which is on your screen. We did example 1Q, which is on your screen. We did example 1 super Q, which is on your screen. And then we met the second session where we did some more practice, and we went over example 1 mega Q. And then we went to example 1 super duper Q, and so on and so forth. So just to recap, let's go over this example. Example 2. Copy this, please, and it reads, find the rational zeros of the polynomial function, then write the function as a product of factors. Function given, f of x equals x to the 4th minus 4x cubed minus 7x squared plus 22x plus 24. Copy that, and we'll do this one together. Now, you don't need the instructions since you already have them from previous sessions. So copy the function. Once again, f of x equals x to the 4th minus 4x cubed minus 7x squared plus 22x plus 24. All right, so we're going to use a rational zeros theorem. What does the theorem say? Well, it says, Mr. Q, that if we have a polynomial and the polynomial has a constant, what is a constant? The number without any variable multiplying it. What is that number? 24. And if you write it in a fraction form over the leading coefficient, what's the leading coefficient? Well, this is in standard form. The number multiplying the variable of the first term is the leading coefficient, so it's an invisible 1. So I write that over 1, and let's see, that is 24. So from here, from this number, we can get all possible zeros, either plus or minus. So what are my possible zeros? So let's see, 1 times 24, 2 times 12, 3 times 8, 4 times 6, and those are all the possible factors of 24, which means that any of those, either plus or minus, could be our possible zero to this function. So where do we start? Oh, Mr. Q, we start with positive 1. Okay, so I'm going to write it over here, positive 1. And let's write our coefficients and constant. What's my coefficient here? 1, negative 4, negative 7, 22, and 24. And let's do our synthetic division here. Bring down the 1. 1 times 1 is 1. Combine, that's negative 3. 1 times negative 3 is negative 3. Combine, that's negative 10. 1 times negative 10 is negative 10. Combine, that's 12. 1 times 12 is 12. Combine, that's 36. Nope, that's not our zero. We go with the next one, which is now negative 1. Same number, but now negative. So I'm going to write it here, negative 1. Same coefficients, 1, negative 4, negative 7, 22, 24. Once again, this is just review. We already did these. I'm just going over it just to get our noodle back, because I know some of you had, you totally unplugged from the matrix. Welcome back. So I bring down the 1. Negative 1 times 1 is negative 1. Combined, that's negative 5. Negative 1 times negative 5 is 5. Combined, that's negative 2. Negative 1 times negative 2, that's positive 2. Combined, that's 24. Negative 1 times 24 is negative 24. And that is our 0. 0. So how do we write that and whatever we have left. Go ahead, Hayden. Tell me what to write, starting with our 0. X.
Oh, it's x plus 1.
And what do we have left?
You have x to the third power minus 5x squared minus 2x plus 24.
Hayden in the house. Let's go. All right. So, and when we got to this, we said we can factor it again, but since we cannot group and end up with 2 factors, we're going to have to do the whole process one more time. So at this point, I'm going to go here. I'm going to use the same factors because we still have the constant of 24. But now I'm going to start with positive 2. I'm going to start with positive 2. And my coefficients here are now what? 1, -5, -2, and 24. 1, -5, -2, and 24. All right. 2 times 1 is 2. Combine, that's -3. 2 times -3 is -6. Combine, that's -8. 2 times -8 is -16. Combine, that's 8. And this is not our 0. So which number do we do next? -2. Same coefficients and constant. -2, 24. Bring down the 1. -2 times 1 is -2. Combine, that's -7. -2 times -7, that's 14. Combine, that's 12. -2 times 12 is -24. And this is our 0. 0. This is our 0. All right. So let's see. Hayden, pass to someone so they can help me and see what we have left here.
Daniel?
Who?
Daniel?
Daniel. Or should we say Danny? What do I write? What's my 0? How do I write my 0?
X plus 2.
Plus 2, and what do I have left over?
X squared plus minus 7x plus 12.
Thank you. And guys, don't forget to bring down the original 0 that we found from the original function. So that is x plus 1. However, are we done? Look at it. Look at this part. What do you think, Michael? Look up, Michael. What can we do here?
We could factor.
Yeah, factor. We got 12 and -7. So factors of 12 that add up to -7. What do you think, Victor? Factors of 12 that add up to -7.
4 and 3.
You said what?
-4 and -3.
Bam, let's go, Victor. You remind me of me in elementary. Let's go. So yeah, so let's factor this x squared. Since it doesn't have a leading coefficient, we can write it as x times x. We got -4 and -3. And if we bring down the other zeros, x plus 2, and we bring down the other one, which is x plus 1. Okay, so now that we have our factors, let's write our function. This was our original, so we write f of x. But now instead of writing this polynomial, we have our factors. What are our factors? X plus 1, x plus 2, x minus 4, and x minus 3. Let's go. All right. So far it looks pretty good, yeah? So let's see. I just sent you a poll from 1 to 5. How comfortable do you feel with these now that we've done some practice? You had some practice over the break. You probably had a math movie night or a math family night doing some polynomial functions, yes? Some of you are like, no, Mr. Q, my family will slap me probably if I give them algebra 2. All right, so we got plenty of 4, 5, 4, 5, 4, 5s, a couple of 3s. Just a reminder today, tutoring at 1 o'clock. So make sure if you need the extra practice, you go there, and we're going to continue doing some more of these. So we're up to right there. So where are we going with this, Mr. Q? Well, let me show you. Today, we're going to be graphing these. But before we get to that, I want to make sure that you understand what we're looking at. So copy this table, please. Title it, go to a brand new page. And at the top, write polynomial function. And we're going to write parent function, graph. Next column is beginning quadrant, and the next column end quadrant. So the first column, parent function, next column, graph, next column, beginning quadrant, last column, end quadrant. And for each row here, empty row, should be 4 empty rows. Leave about 6 lines of space because we're going to need plenty of space to graph. Okay? Prep that, please. I'll give you some time. Ready? Go. All right. So you have plenty of time to get your table ready. So this is what we're going to do. I'm going to go and get started with the first function I gave you at the beginning of the school year and then how we progress to where we're at right now. So we are looking at the polynomial functions up to right now. Okay? So here we go. I'm going to start with the parent function of the first function I introduced at the beginning of the school year. So write this down. The first function I introduced was f of x equals x. F of x equals x. And what is that function called? This is known as a linear function. Why is it linear, Mr. Q? Well, look at the exponent. What exponent does it have? Oh, it's an invisible exponent. Yes, it's an invisible 1. Make sure you mark it, invisible 1. All right, and how does that graph look like? All right, so let's graph this. All right, so before I graph it, just to, I'm going to take you back to elementary, some of you. Let's mark the quadrants. They're called quadrants because it's 4 of them, quad meaning 4. And we always start at the top right and go counterclockwise. So this is quadrant number 1 over here. This is quadrant number 2. This is quadrant number 3. And this one down here is quadrant number 4. Okay? So we said this is a parent function of the original function that we introduced, and we always start from the point of origin at 0, 0. Now, why is that? If it's a linear, what's our constant? Oh, there is nothing there, Mr. Q. That's why we start at 0. Our y-intercept is 0. There it is. So what is our slope? It's an invisible 1 or 1 over 1. That means we go 1 step up, 1 to the right, 1 step up, 1 to the right, step up, 1 to the right, 1 step up, 1 to the right. And if we plot our graph, there it is. This is our f of x equals x. Okay, so since we always read graphs from left to right, which quadrant do we start at and where do we end? What do you think, Jesus? Which quadrant do we start at?
Wait, what was the question again? I was doing the graph.
So if we're graphing any graph that we graph, we always read it from left to right. So which quadrant does that graph start at?
Quadrant 1.
We always graph from left to right. So follow the graph from left to right.
3.
3, yes, it starts right here. So if we were to graph that, it starts at 3, and that means it ends at quadrant 1. Okay. All right. So that was the first function that we introduced, f of x and x to the first power. From there, I gave you this next one, f of x equals x to the what? To the second power. Now, Does anybody remember the name of this one? Yes, Mr. Q, it's a quadratic. All right, so let's graph that one. And by now, these should be a piece of cake because I've been giving you plenty of practice on these on the warm-ups. I'm no longer going to mark my quadrants, but let's graph this. We always start at 0, 0, and that graph looks like this. And we already did that on the warm-up, right? There it is. All right, so if we're reading it from left to right, what quadrant does it start and where does it end? What do you think, Angie?
2 and then 1.
2 and 1, that is correct. Thank you, Angie. All right, next. So let's see, we went from parent function f of x equals x to the first power, which is a linear. Then we went to f of x equals to x to the second power, which is quadratic. What do you think will be next? F of x equals to what? X to the, yeah, I see you guys saying 3. Either that or you're in the Hunger Games, right? One time, Miss Tucker, we were in class, and I remember I was asking for volunteers. Somebody threw that sign and did the whistle. I'm like, oh no, you didn't say that. It was so funny. Anyways, let's graph this. Any volunteer? All right, here we go. So once again, I'm not gonna label my quadrants, but let's graph this. Once again, it goes through the point of, oh, I didn't label this previous one, f of x equals x squared. All right, so point of origin, there it is. And what does that one look like, guys? It starts from the bottom, it curves, goes through the point of origin, it curves again, going to the top. There it goes. You guys remember that one, yeah? And this is known as a cubic. Okay. All right, and once again, where does it start and where does it end? What do you think, Jaziel? Where does it start? If we read it from left to right, and where does it end?
It starts at 3 and ends at 1.
Let's go, Jaziel. Come on. Yes. So let's see. We went from f of x equals x to the first, f of x equals x to the second, f of x equals x to the third. Guess what's coming? F of x equals what? Yeah, x to the fourth, thank you. Yeah, some of you are like right there with me. So yeah, so let's graph this one. All right. Now, once again, it always goes through the point of origin. Now this graph is kind of funky, but you know, it's still a graph and we're still gonna be using it. And this is known as, check this out, look up, to the fourth power. It's usually called quartic. Quartic is quartic. Anyways, look up and it goes like this. Start from the left, gets really close, goes through the point of origin, barely touches it, and it ends up over here. All right, this is f of x equals x to the fourth. All right, and this one I forgot to label, f of x equals x. Yes?
Can you do that again? I didn't understand it.
Nope.
What the graph looks like. It just looks like a quadratic to me. What is it like?
This one?
Yeah.
Oh, this one?
Mm-hmm.
Yeah, it does look like a quadratic, yes. The only thing, notice that.
Can you like redraw it? Like do it again? I don't understand.
Yes, give me a second. There it goes. We start over here. Come down very close to the x-axis. Don't cross it. Go flat through the point of origin. You're still flat, not crossing the x-axis, and then come back up. So imagine you are an X-Wing fighter and you're about to bomb the Death Star, and you don't cross that barrier or else you're gonna crash. So you're like, but Hayden said, you know what, Mr. Q, it looks totally like quadratic. Yes, this quartic looks like a quadratic. Quartic being 4. And where does it start? Yes, second quadrant and ends first quadrant. Okay. Now let me show you something, guys. Write your utensils down, look up to the screen. Now, by looking at it, by now, hopefully you see some commonalities. Who sees that this one starts in quadrant 3 and ends in 1? Okay, yeah, I see that, Mr. Q. Is there another one like it? Yes. Quadrant 3 and ends in 1. Okay, now check this out. Look up, guys. This one that starts in quadrant 3 and ends in 1 has an exponent of 1. Okay. This one that starts in quadrant 3 and ends in 1 has an exponent of 3. Oh, okay. Kind of see what you're talking about. Yeah, some of you are like, already side. I got you. Hold on. Don't say it out loud. Let me go to the next one. Look at this one. This one starts at quadrant 2 and ends in quadrant 1. Is there another one like it? Yes. Quadrant 2 and ends in 1. Now, what is the exponent of this one? Exponent of 2. And this one is an exponent of 4. So if you were to write a note to yourselves to be looking out for something, what would we say that this first one has in common with this one because the exponent is what? What would you say, Hayden?
They're like odds and evens.
Odds and evens, yes. The odd number exponents start at quadrant 3 and end in 1. Let me repeat that again. Odd number exponents, their graph starts in quadrant 3 and ends in 1. You make a note for yourself. I'm not going to write it on the screen. You write it on your own paper. So if that's true for odd number exponents that start in quadrant 3 and end in 1, what would be the other note that you would write? Octavio. Octavio. Not there yet? Okay, help him out, Victor. So if this one was odd number exponents start the graph at quadrant 3 and in 1, what would you say for the other two? These are odd number exponents, the yellow ones. What would you say for these?
Even number.
Even number exponents, their function starts at quadrant 2 and ends in 1. Very good, yes. Now, just to close this part, since we're just about done, look up. Let's see if you remember. Look up. If I gave you f of x equals negative x, what does that do to the entire function, everyone? Show me with your hands or fingers. What does that negative in front of the function do? Yeah, I see some of you that it flips, so that's true. So we start at the point of origin. However, this one flips to its inverse. Inverse, there it is. And that would be f of x equals negative x. So if that's same for that, what would it do to this one again? Negative x squared. Again, it flips. So we do the upside down. So this is f of x equals negative x squared. Same thing with this one, f of x equals negative x cubed. It does what? It flips. So instead of starting at the bottom from left to right, it can start at the top from left to right. There you go. And this is f of x equals negative x cubed. And last but not least, f of x equals negative x to the fourth. It starts from where? From the bottom through the point of origin, meaning it barely touches. It comes up the other side. F of x equals negative x to the fourth. All right, guys. So now, why did I want to give you this? Well, because for tonight, you have to graph functions. And you need to know what you're looking at. So check this out. Look up to the screen really quick. Not that one. Not that one. Let's go with this one. Writing utensils down, look up to the screen. Look up, look up, look up, look up, look up, look up, look up. Look at that function. What is the highest degree of that function? Everybody got it? Highest degree is what? 3. For those of you that don't see it, it's right here. That's the highest degree, which means the parent function of this one would be what? F of x equals what? X cubed. So if I was to ask you to tell me where does this graph start and where did it end, what would you say? Where does it start? Quadrant what? 3, which is down here. And where does it end? Quadrant 1. Doesn't matter what happens in between, but do we know where does it start and where does it end? Yes. Okay. With that same thing, look up. Look at this one. What is the highest degree of that one? Same. 3. Where does it start? The third quadrant ends at 1. Okay. Well, with that same idea, look at the previous problem that we just did. Look at this one. Let's go back to that problem. Get that in front of you. And I want you to down here, leave some space. Down here, I want you to create your coordinate plane. There it is. So, look at the original function. What's the highest degree of that function? Angie, what's the highest degree?
4,
So where does it start and where does it end? Angie.
2, and it ends in 1.
Yes, so then I want you to graph right here like a little beginning arrow pointing upward on quadrant 2 and an end arrow at quadrant 1. There it is. Okay, so we know the beginning, we know the end, so now we want to know what happens in between. Y'all ready? All right, look up to the screen. Look up, look up, look up. What's the next step, Mr. Q? So for here, we need to find, we found the factors, but we still haven't written our zeros. How do we write our zeros? Look up, we set it equal to 0. And we write x plus 1, x plus 2, x minus 4, x minus 3. Now that we have all these factors equal to 0, what do we do next? Set each one equal to 0. So I'm going to write this one equal to 0, x plus 1 equal to 0. This one, x plus 2 equal to 0. This one, x minus 4 equal to 0. And this one, x minus 3 equal to 0. And we solve. Here we go. Minus 1, x equals negative 1. Minus 2, x equals negative 2. Plus 4, x equals 4. Plus 3, x equals 3. And once again, what are these called? Mia, what are all these called now that we finish up to right there? Very good. Anthony, what are those called now that we've solved it? These are my solutions. What else?
Roots.
Roots, what else?
X-intercepts.
X-intercepts, yes. And zeros. So if we were to substitute all these, it's going to give us zeros. But now we know that they're called what? X-intercepts. So let's plot these. Here we go. My first x-intercept is at -1. -1 is right here. Plot your 0. There it is. What is the next one? -2. -2 is about right there. Plot your 0. There it is. The next one, x equals 4. X equals 4 somewhere over here. This is 4. And x equals 3, which is somewhere right there. There it is. All right. So let me move this over this way. There it is. Okay. So look up. Let's graph this. I'm going to start from the left side. I'm going to go down through that first one, then through the second one, and then come back through the next one, and then through the next one. Here we go. So I'm going to go straight down through -2, then come back up through -1, come down to +3, then through 4, and then we end up on that last arrow that we did. There it is. Let's go. This is our f of x. I'm not going to write the entire polynomial, but that's our f of x graphed. You're like, that's it? That's it? So what is the purpose of doing that little table so that you know where it starts and ends, and then you just need to use your zeros to graph it, okay? So before I elaborate on something else, let's see. How do you feel with these so far? 1 through 5, it's on your screen with the graph. We did the work already, plenty of practice. 4 5s, 4 5s, 4 5s, 4 5s. 1 3, 1 2, 4 5s, 4 5s. Okay, once again, this just requires practice. If you've been practicing, the work should be done. Now the only thing that we added was what? The graph. Okay. Any questions up to right there? No, Mr. Q. All right. Now, one last thing. Let me show you something really quick. What if, after you did all this, look up, you ended up with something like this? Let's see. Let me do a new screen. Let's say they gave you whichever function. And I'm not going to go over it, but let's say it was to the 4th power, yada, 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 yada. And I'm going to erase these so like that you don't get confused with that. But, you know, they gave you all that with some numbers there. And at the end, you came up with x equals -2, x equals -1, x equals 3, x equals 3. You're like, oh. Whenever you end up with 2 that are the same, this is called duplicity. What is it called? Duplicity. Tell your neighbor right there, whoever's there, your dog, your cat, your bird. And how do we graph that? Let me show you how to graph that. Pay attention, this is the last piece. What is my first x-intercept? -2. What is my next one? -1. What is my next one? +3. And my next one, also +3, I'm going to make it bigger. Why, Mr. Q? Let me show you why. Once again, this is to the 4th power. That means it starts over here and it ends over here. So look, go down, through. Instead of going through this one, you barely touch it and come back up. That's what that duplicity does. Whenever it's a double root or a duplicity, you just touch it. You don't go through it, because if you go through it, then you should have another root over here, but we don't. Okay? We good? Yes? All right. All right, guys. Well, that's going to be our session for today. Once again, your home play, you wrote it down. Make sure you get me all the graphs for those. Tutoring at 1 o'clock. Have a good one, guys. Enjoy your home play. It was nice seeing you back. And I'll see you guys. Hey, we see each other tomorrow again. Let's go. Peace. Bye. Bye. Have a good one.